You might ask, what are we going to talk about in this video? Let's refer to the essential question. Here we go. How do you solve rational exponent equations? And here we go. Oh boy, not another one. You might be thinking, okay, what are those things? Well, let's break it down. Equation means we got this, and an equal sign. Very similar to our radical equations we just chatted about. It's an equation. A rational exponent equation is an equation in which there is a rational exponent somewhere. Maybe there's a bunch, maybe there's just one. And you might be thinking, what's a rational exponent? We should know. Simple example. We have a variable, whatever. We have it equaling some number, I don't know, 12, doesn't really matter. But I don't have a rational exponent yet, my friends. I will now. Let's say this is a 3/4 power. There is your rational exponent. So as soon as you have an equation where there's a rational exponent, this is what we're going to talk about in this video. And you can have other things. You can have maybe a 3 here. There you go. That's another example. You can have an equation that looks like this. Something where there's a 2 and then x plus 1 raised to the 1/2 power equals 10. Bingo. Rational exponent equation. So let's talk about how in the world we solve these things. Well, I'm going to tell you, it's very similar to what we did when we talked about radical equations, because there are two goals. Goal number one is to get the power by itself, aka we're going to isolate the power. And you do it exactly like we did with radical equations. First you're going to undo subtraction addition, if it's there, and then you're going to undo multiplication division, if it's there. Our example in blue right here, if you notice, it is a rational exponent equation because there's a rational exponent there. Well, my first goal is to do this. In solving it for x, that's isolate the power. So this, be careful, this x is what's being raised to the 1/2 power. So that is my power. Therefore, I'm going to get that thing by itself by getting rid of the subtraction of 36. Add 36 to both sides. That gives me 36 over here. It gives me 2x to the 1/2 over there once this is gone. So I still haven't achieved goal number one, but I can by now undoing my multiplication division. Since it's 2 times x to the 1/2, I divide by 2 to clear out the 2's. And then 36 divided by 2 is just 16, or 36 divided by 2 is just 18. Sweet. So there is goal number one. I've gotten the thing that's powered to the rational exponent by itself. That's goal one. Here's goal two. You must free the variable, just like we did with radical equations. But that's free the variable, or the variable expression, by raising both sides of the equation to the reciprocal power. Let's refresh what reciprocal is. Over here is an example. 1/2 is an could be an exponent. It's just a fraction. But the reciprocal of that, remember, is when you take the numerator and the denominator and you flip them. So this 2/1 would be the reciprocal of 1/2. Well, the reciprocal of 3/4 would just be 4/3. Remember, you just take these things and flip them. Flip them. That's reciprocal. Phenomenal. So, back to this. If I go to my x to the 1/2 equals 18, here it is. If I'm going to free the variable, it's as if that variable is locked by that rational exponent. You're not being rational. That's what you got to free it from. I don't know. So this thing, I need to raise this expression to the reciprocal power of 1/2, where the reciprocal power is 2/1. Ha! So if I raise that to 2/1, I also have to do it on the right side. So 18 to the 2/1 power, that's weird. Oh, don't get confused. 18 to the 2/1 power is just 18 squared. That's all it is. So 18 squared is 324 regardless. Over here to the left, so you understand how this happens. Remember, when you're raising a power to a power, you multiply the exponents. So what's 1/2 times 2/1? Last I checked, my friends, that's 2/2, which is just 1. So when you multiply these powers, it really just makes a 1 exponent up there. So that's why it's freed. It's just x to the first power. So there's no more exponents up there other than 1. So there's your answer. So that's it. Goal 1 and goal 2. That's practice. Example number 1 and example number 2. Well, before we get there, sorry. Why do we do this reciprocal power? Well, real quick, if you look at this simple equation, rational exponent equation, this x to the 1/2, remember, is the same as the square root of x. Well, you could look at this equation right here and say, okay, hold on. What could I put in for x that would make this equation true? Well, okay, so what's square rooted would give me 5. Well, that's simple, 25. So 25 would certainly work because the square root of 25 gives me this. But going back to the last video, the square root of x, to free that variable, I must square it because the square and the square root will cancel. Well, if I square this, I must square this. Oh, look. If I square it, I must square it. So it's the same thing, exact same thing that I'm doing here. It just so happens that when I multiply, these just kind of cancel out, so I just be left with x. So there you go. Sweet. So that's kind of why you do the reciprocal power, because it is the same thing as what we just talked about with radical equations. You would free the variable by getting rid of the square root by squaring. Same concept. Okay. So now, let's get to example 1 and 2. Here we go. So here's your equation. Solving for x. X to the 1/3, plus 6 equals 12. Well, I must do goal number 1. Let's get this thing right here, this guy, the thing that's being raised to the power by itself. To do that, let's subtract 6. Subtract 6. So that gives you a 6 on this side. And there we go. Goal number 1 is achieved. I've got the thing that's powered by itself. Let's go to goal number 2. I must then raise each side of this equation to the reciprocal power. Bam, did it. So when I do this 3/1, that's really the same thing as cubed. So these really kind of cancel each other out. That's why I'm left with x. And then 6 to the 3/1 is the same as 6 to the 3rd power. So 6 times 6 times 6 gives you 216. There you go. Sweet. Rock and roll. Example number 2. Well, here's a little trickier one, because if you look, I do have a rational exponent equation, but here, ladies and gentlemen, is the entire thing that's being raised to the power. So I must get that whole thing by itself first to achieve goal number 1. Well, here's how I do that. I get rid of the addition by subtracting 2. Subtracting 2, that gives me 3 here. And there is goal number 1 achieved. I have this thing that is raised to the 1/2 power by itself. Now I know it's ugly, but that's exactly what you do. So now let's go on to goal number 2. We must free this stuff that's being raised to that 1/2 power. How do I do that? Well, I would actually do this. I would take, let me erase this. I would take this guy, and I have to raise the entire thing to the reciprocal power. That is 2/1. Oh, don't forget, I have to do it over here too. 2/1. So over here on the left, these guys cancel out, and I'm just left with 4x minus 7. Oh, look, there you go. So it's free to do it at once any old time. So over here to the right, 3 squared is just 9. So then I have a simple equation right here that I've solved way back in the day. Very simple. So add 7 to both sides, you get 16. Divide by 4, you get x equals 4. Sweet. And there you go. Let's go to some other examples. Example 3 and example 4. Wait a minute. What up with these? These are definitely a little different, because look, my rational exponent now is 3/4, and my rational exponent is 2/3. Oh boy. Well, it's no different. Goal number 1. I must get this thing that's being raised to the power by itself. Well, that's undo subtraction and addition. Well, there isn't any. Okay. So then we must undo the multiplication of the 4 by dividing by 4. By dividing by 4. So this cancels. I'm left with x to the 3/4 power. Sweet. Goal number 1 is achieved. I've got the thing that's raised to the power by itself. Awesome. And then 108 divided by 4 is 27. So now I must go to goal number 2. I must raise this thing by the reciprocal power of 3/4. Well, that happens to be 4/3. Don't forget, got to do it over here too. Okay, so when I do this and I multiply that, it actually just gives me a 1. If you don't believe me, take your calculator. Put 3/4 times 4/3. You'll get 1. These cancel out. That means I'm just left with an x. Sweet! There's goal number 2 achieved. Over here on the right, that means when I take this 4/3 and I distribute to the one exponent up there, I get 27 to the 4/3. Now that is not my final answer. I got to do a little bit more cleaning up for this one to be right. So here's how this works. Remember, we chatted about this. The thing that's in the denominator is like the roots of the tree. So that's my root. The thing that's up here is like the power. And we talked about the tree. Woohoo! And this right here, being the ground, that's the fraction bar. Down here's the roots. So 3 and 4. That's the power. That's the root. That's the power, 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 root, root, root. Woohoo! So, let's clean this up. Well, that means I can do the cube root of 27. That's just a 3. So 3 to the 4th power is 81. And there you go. A little bit of work involved. I like that one. That's cool. Okay, I want you to pause the video. Here's the example I want you to do. X to the 2/3 plus 15 equals 24. Solve that for x. Exactly with the steps that we just did. Pause the video, and I'll come back and show you the answer. Good luck! Alright, I'm back. Let's see if you got the answer. Very first thing, goal number 1. Get the thing that's raised to the power by itself. I do that by subtracting a 15, which gives me x to the 2/3 equals 9. There's goal number 1. Goal number 2, let's free the variable by raising both sides to the reciprocal power. Therefore, it's 3 over 2. 3 over 2. So when I distribute this, these cancel. I'm left with x equals 9 to the 3/2 power. Now you can leave it that way, but you'd be wrong. You need to clean it up, just like we did in the last example. So this is the same thing. Here's my my root. So it's the square root of 9, that raised to the 3rd power. Well, let's clean that up. Square root of 9 is just a 3. And then 3 to the 3rd power, oops, sorry, x equals. So 3 to the 3rd power is just 3 times 3, which is 9, times another 3, which is 27. So my answer, lovely, is right there. X equals 27. Did you get it? Did you? Did you get it? Hope you did. See you in class. Peace.